still continue on to solve systems with three variables. So looking at this system, we've only learned elimination so far. So we need to add up two equations to eliminate a variable. If you look at equations 1 and 3, our z will easily eliminate, so I would combine those together. And then do equations 1 and 2 to get your a and b. Add those two up and you should get y equals -1. And then plug them in to find x, and then plug them both in to find z. So our final solution is 2, -1, 1. The next method we're going to be doing is substitution with three variables. Again, it's the same concept as two variables, but just have to do it twice. So looking at our first equation, we first have to solve one of our equations out for a variable. So again, just like before, I would number equations 1, 2, and 3. And we have to figure out what variable we want to solve for. So I'm going to solve equation 1 for y, which means I get y by itself and move everything else to the other side, so that y equals -3x plus 2z plus 10. From here, we have to plug in y into equations 2 and 3. So if we start with equation 2, we solve for y, so we have to replace y with our equation. So we'll have 6x minus 2, and I see a y, so I'm going to substitute in my expression for y, which is -3x plus 2z and we got to finish off the equation, so we have plus z equals -2. Now we're going to finish solving this out, or combining like terms. So we need to distribute and then combine our like terms. When we do that, we will get 12x minus 3z equals 18. And this will be our equation A. And then do the same thing for equation 3. Since we solved equation 1 out, we don't have to plug it back in there. So do the same thing for equation 3. Substitute in our expression for y there. And when you do that, you should get -11x plus 11z equals -33. Now this will be equation B, and now it's like we combine elimination substitution together. We substituted in y, and now we're left with equations with two variables. I will then add up equations A and B to eliminate one of our variables. And when you add up equations A and B, you're going to have to multiply each one by the opposite number. And when we add up A and B, we are eliminating z, so we get x to be 1. And then we plug that back in to find z, and then once we find z, plug it back in to find y. When you do that, you should get 1, 3, and -2 for your solutions. So I'm going to leave you to the next one. Again, solve one of them out for a variable. I would solve equation 1 out for x, plug it into equations 2 and 3. And when you plug it into equation 2, if you notice when we combine like terms, our y's and our z's cancel out and we're left with 4 equals 6. Since that is not true, we can stop, and this system has no solution. And our last one, again, solve one of the equations out for a variable. And I would solve out equation 1 for x, plug that into equations 2 and 3. That will give us a and b. And we can then add up our two equations and solve for our variable. And when we do that, and we solve them all out, we get x equals 15, y equals negative 12, and z equals 0. And this is what we're working on tomorrow in class.